If I gave you 10 days, what could you build? A website? An app? What if you built something that would change the entire world? This is the story about JavaScript.
JavaScript.
What is JavaScript?
Little bits of JavaScript, which is a kind of computer code.
And how it accidentally became the most successful programming language in history. In 1995, Netscape completely dominated the web browser market. But then a little company named Microsoft entered the arena with Internet Explorer. Knowing Netscape needed to become more dynamic, they called upon Brendan Eich and gave him 10 days to come up with a new dynamic language. I don't know about you, but you would have found me in the fetal position. But after 10 days, Brandon emerged with Mocha. He incorporated this prototype-based object model and first-class functions. This approach treated functions as variables. But prior to its release, Mocha was renamed to LightScript, but then later to JavaScript. It seems like this was strictly marketing. The only advantage I could see was that it portrayed some sort of support language to Java. But what came next, no one could actually predict. So you've probably heard about the browser wars. If not, this was when the early days of JavaScript were like the Wild Wild West. Every browser had its own rules and its own way of doing things. This was due to Microsoft reverse engineering JavaScript to come up with a similar language they called JScript. This resulted in 2 versions of JavaScript, but with no standards. Now, as you could imagine, this caused complete confusion and headache for developers. One version would work on this browser, but was totally useless on another browser. Now, let me show you what those developers were dealing with. This code here is pretty simple, right? But back then, here's how it looked across different browsers. It must have felt like pure chaos. But this chaos led to something amazing. It forced Netscape to turn to the European Computer Manufacturing Association, or ECMA, to ask them to standardize JavaScript. Now, you've probably heard of these standards. We have ECMAScript 2, and this came with standardizing ISO. Then ECMAScript 3 gave us regular expressions, new string methods, concat, match, replace, slice, split, etc. Each of these standards brought new functionality to JavaScript, and poof, all of a sudden, developers could write code once, and it just worked everywhere. Now, why was this revolutionary? Well, development time was essentially cut in half. The code became more reliable, which then caused web applications to become more ambitious. And all of this leading us to Ajax, which is a set of techniques on the client side that allowed for asynchronous web applications. Now, this is all great for the client side, but JavaScript wanted more. Now, for years, JavaScript was trapped in the browser. But then Ryan Dahl came around and he asked one simple question. What if we could just use JavaScript everywhere? This idea sparked the creation of Node.JS. Now, Node.js wasn't just a new tool, it was a completely new way of thinking about JavaScript. Let me show you what made it special. Now, you see this? This is Node's event loop in action. The code begins to execute, hitting this console log statement, and printing starting. The fsRead file function is then called. This then initiates an asynchronous file read operation. Now, instead of just waiting for the file read to complete, Node.js will just move on, and it continues executing the next line, which prints ending. That file read operation is now offloaded to the system kernel. Meanwhile, the event loop continues to check for pending tasks. Once that file read decides it's complete, the callback function is placed in an event queue. That event queue will scoop it up and execute it, and it prints the file content. This is why companies like PayPal switched their entire backend to Node.js and saw double the requests handled per second, about 35% faster response time, and 40% fewer files of code. So now JavaScript can live on the client side and the server side. But what's the next steps? I love this quote. To sustain longevity, you must evolve. That's Ari Spears. So let's take a look how JavaScript evolved from a simple language to a development powerhouse. The first step led to frameworks. This made it much easier for smaller teams to grow at a more rapid pace. Now, with these frameworks, React brought us component-based thinking, Vue made it progressive and approachable, while Angular just gave us a complete platform. But the real magic happens in the next iteration. Modern JavaScript has added a bit more structure. This was done with TypeScript, a superset of JavaScript that will essentially compile down to JavaScript. Now, all of these evolutions basically gave us frameworks that allow code changes to reflect instantly, and with TypeScript, we can now catch errors before they happen. This would have seemed like science fiction in 1995, but the results speak for themselves. Modern JavaScript apps are 50% faster to load than prior applications. They're more reliable thanks to type checking and easier to maintain with these modern tools and frameworks. So, what does the future hold for JavaScript? Let's talk about where JavaScript is heading, because this is where things get really interesting. There are three major shifts reshaping what's possible with JavaScript. Remember when people said browsers couldn't handle complex applications? Well, webassembly changed all that, which is a low-level assembly language with a binary format. This can near native performance of languages like C, C++, or even Rust, with a compile target to work on the web. Now, this was actually designed to work alongside JavaScript in the browser. Let's take Figma for example. It's basically Photoshop in the browser, and it's running at near native speed. That's what happens when WebAssembly and JavaScript work together. Looking at these numbers, we're talking about performance that would have seemed impossible in the browser. Here's something wild. You know how AI is everywhere? Every time you change the channel, every video you watch, it's all about AI. Well, JavaScript is now there with it too. With tools like TensorFlow, we're running serious AI models right in the browser. Let me show you what this means in practice. Do you see this real-time object detection? It's running entirely in your browser. There's no server required. That's the power of this new age JavaScript. But this is where things get really powerful. Instead of running everything on these big centralized servers, we're pushing JavaScript to the edge of the network. Think of it like having these mini servers all over the world that are running your code, closer to your users. What this does, it creates the ease of the deployment process. And that's why companies like Cloudflare and Vercel are betting big on edge computing. Now, out of everything we've covered today, you know what the most fascinating thing about JavaScript's story? It was never supposed to be this big. But here we are, 25 years later, it's powering everything from Netflix's interface to AI models in your browser. Heck, it's even probably powering that subscribe button below. Now, these numbers are pretty mind-blowing. 98% of websites use JavaScript, and there are over 20 million JavaScript developers worldwide. And that NPM registry has more packages than any programming language. But what really matters isn't the numbers, it's what they represent. JavaScript succeeded because it evolved alongside the web itself. Every time someone said, "You can't do that in JavaScript," someone else proved them wrong. And we're not done yet. With AI, edge computing, and WebAssembly, JavaScript is now pushing into territory that would have seemed impossible those first 10 days. The web's future is being written in JavaScript. So what are you going to build?